Hello everyone, my name is Shashank, Master Teacher of Mathematics at Vedantu. We are presenting solutions for JEE Advanced 2020 Paper 2. Here in this video, the question is related to functional equation and differentiability is being discussed in this question. Let's have a look at the problem. It's a good level problem. Let f r2r and g r2r be functions satisfying f of x plus y is equal to fx plus fy plus fx into fy, and g is the function such that fx equal to x into gx for all x belongs to R, real numbers. If limit of gx when x tends to 0 is 1, then which of the following statements is are true? So one or more option can be correct here, right? Looking at the option A, f is differentiable at every x belongs to R. Option B, if g0 is 1, then g is differentiable at every x belongs to R. Option C, the derivative f dash 1 is equal to 1. Option D, the derivative f dash 0 is equal to 1. So basically we need to check the differentiability of f and g, right? It is nowhere given that any of these function is differentiable or continuous. Yeah, so we cannot go for direct differentiating the given relation or assuming the function to be exponential or something. So we need to go for the first principle, basic idea, right? Let's check another page. So I'm rearranging the given relation in the manner like f of x plus y, I can write minus fx is equal to, if I take fy common, then 1 plus fx from the remaining two terms into fy, and I am going to divide this by y. Why I am doing this? Because I am in this way will get going to make putting limit y tending to 0. So in the left hand side I have made f dash x, which was needed to be checked. In the right, limit is on y, so I can take 1 plus fx common and limit fy upon y tending to 0. And if you look carefully at the problem, limit of gx is 1 and gx is actually fx upon x. So I can write it as 1 plus fx limit y tending to 0 gy, and it is 1, so it is finally 1 plus fx, right? So from here directly we can say that f dash x is 1 plus fx for all x belongs to R main, and f is defined everywhere. So f dash x is defined everywhere, f is differentiable, it means everywhere. So option A must be correct. Going for little integration at this step, we'll get to know fx also. But in order to hit the option A, check the option A, it is sufficient to say that f is differentiable everywhere. And one more thing, if you put 0 over here, then f0 will come to be 0, because 0 into g0 is something which is not known but is defined everywhere. As g is defined everywhere, g0 must be something finite. So f0 we can say directly is 0, and then f dash 0 would be 1 plus f0, that is 1. So if you look at the option A is correct, option D is also correct, but we need to check option B and C also. So going for little integration over here, we can say if you take 1 plus fx in the denominator of left hand side and integrating it, you can easily get that ln of 1 plus fx is equal to x plus c, and from here fx would be something k e raised power x minus 1. But as f0 is 0, right, if you put x equal to 0 over here and f0 is 0, so we can say that fx has to be, I mean, in that way we got k as 1, so e ka power x minus 1, because from here you'll get k is equal to 1. So finally we got fx as e raised power x minus 1, which is again easily seen to be differentiable. Now coming to, and we can verify the option C from here, that f dash 1 would be e, but in the option it was given f dash 1 is equal to 1, so option C is not correct. Now coming to the option B about g function, g0, if g0 is 1 means g0 is not given in the original paragraph of the question. For option B only g0 is, we can use this information that g0 is 1, then g is differentiable at every x belongs to R. You need to check. You can say that gx is fx by x whenever x is not 0, that is obviously e ka power x minus 1 by x whenever x is not 0. But in this option number B, g0 is given to be 1, so I can write it is 1 when x is 0. Now going for the derivative of g dash x can be written as, from the first principle again, limit okay, gx is differentiable everywhere. It is very well, I mean, clear from the function e raised power x minus 1 upon x. The only doubtful point is we should check the differentiability at 0. So we need to check differentiability only at x equal to 0. Clearly it is differentiable everywhere, so the only doubtful point is x equal to 0. Other than this point, the function gx is differentiable everywhere, is very clear. And checking differentiability at 0, the formula for g dash 0 is limit of gx minus g0 upon x when x tends to 0. And as gx is e raised power x minus 1 upon x whenever x is not 0, and g0 is 1, so I'm writing 1 over here by x and finding this limit, which is, I mean, looking an easy limit to solve. Here we can go for expansion of e raised power x, or for the L'Hopital rule, I'm going for L'Hopital here, differentiating numerator and denominator, because it was 0 by 0 form. And here now we can directly use the standard limit e raised power x minus 1 by x, which is 1. So answer here is half for g dash 0. So g actually was differentiable everywhere, but only doubtful point was x equal to 0. There we checked the differentiability and it is coming out to be half. So g is differentiable everywhere. So option B is also correct. I hope you understood it. So option A, B and D are correct. Everything whatever I have explained is here typed also. You can go for it. So thank you. Stay tuned for the next question. I hope you understood it. You liked it. Thank you.